Yet another class. I'm Dr. B. I'm your chemistry teacher online, and today we are going to be looking at determination of oxidation number. Now, this is a very important topic, and it used to be an issue somehow to a lot of students, even those who are graduates. How do we obtain oxidation number for various compounds, various species in different compounds? But now the question is the relevance of oxidation number. But what is oxidation number? Usually every atom is always identified or assigned with oxidation number in a substance. All right, so if you have a substance or a compound, for example, like what we have here, potassium tetraoxo manganate 7, okay, then you have this is potassium heptaoxo dichromate 6, or hydrogen tetraoxo sulfate 6. Now all these compounds have oxidation number. They have a number that's assigned to the various atoms in the substance, and that number is important because in the naming of these very compounds, usually they are named with respect to their oxidation numbers. So when you have, for example, something like this, you have this, this is iron 3 chloride and this is iron 2 chloride. In the naming of these compounds, like iron 2 chloride, iron 3 chloride, they are being named with respect to their oxidation number. So when you said this is iron 3 chloride, this is simply the oxidation number of iron in this compound. And they play a serious role. Apart from the fact that these numbers that you have here, these oxidation numbers you have here, play a role allowing you to be able to name compounds, they also allow you to be able to determine which part of this particular compound in a chemical reaction is oxidized or reduced. It also helps us to understand the various increase or decrease in certain oxidation numbers with respect to the various compounds that you find them. They play a central role because their presence in compounds is the citadel, is the main element, the main species that is playing the role of either oxidation or reduction, because it is that particular element, apart from giving the name of the compound, it's also there to help you understand that, look, the oxidation process, the reduction process, I am the one who causes it. So oxidation numbers in every compound that you have is assigned to atoms, and it allows us to be able to understand the nature of the atoms that you have in the compound and the role they play in terms of what compound is oxidized, what compound is actually reduced. So oxidation numbers are very important, they are very relevant. But in this class, we are not talking about oxidation reduction because there is a previous class that we had already discussed oxidation reduction reactions. So how do we calculate oxidation number? Now if you see potassium is having +1, you must know that usually oxidation numbers of group 1 element used to be +1 because of their positions in the table, okay, in our usual periodic table. So they take the position of 1, and usually they are assigned oxidation numbers with respect to their positions in the periodic table. Now you can see manganese is +7 and you can see oxygen -2. There are situations where oxygen is even -1. Now how do we determine this +7 that we have here for manganese? How do we determine this +6? Because these oxidation states are what is being used to name this compound. Remember that I had said this is simply potassium tetraoxo manganese manganate 7. So the compound is named with respect to this particular this particular element oxidation state. And here too, you also have potassium heptanoxodichromate 6. You see that the compound is named with respect to the oxidation state of chromium in this compound. Now, how do we come about all this? How do we come about this issue of iron 3 chloride, iron 2 chloride, okay, manganese 7, and then a chromium, chromate 6, sulfate 6? How do we come about all this? We can calculate this. Now, let us see how we can calculate this. Okay, now let's look at this first. Now, here the question is simple. Determine the oxidation number of manganese in potassium tetraoxomanganate 7. Determine the oxidation number of manganese. You may not be given the name as I'm saying, potassium tetraoxomanganate 7. You may just be given the molecular formula in this way, and you are asked to look forward the oxidation number of this manganese, oxidation state of manganese in this compound. Now, let us look at something. To look for oxidation state, this is how it goes. Now, we will say potassium, okay, we will have oxidation number, permit me to use in the short form, oxidation number of potassium plus manganese, oxidation number of manganese plus 4, which is this, to the oxidation number of oxygen equals to 0. That is how we place it. Oxidation number of potassium plus oxidation number of manganese plus 4 times the oxidation number of what? Of oxygen. Okay, oxidation number of potassium, we already know that is plus 1. The oxidation number of manganese, we do not know, because that's what we're trying to look for. The oxidation number of oxygen is minus 2, okay? And then we now fix this into this equation. Okay, we now fix this into the equation, substitute into the equation. Remember that this is just given. You will not be given any of these red oxidation numbers here. You will just be asked to calculate. You need to know what the oxidation state of calcium is, of potassium is, of oxygen is, of hydrogen is. You need to know, as a chemist, you need to know what their oxidation states are. Okay, now when we substitute this here, we are told that potassium is plus 1, so it means that potassium is plus 1 plus manganese we do not know plus 4 times oxidation state of oxygen is minus 2 equals to 0. Right, now with this it's simple. So we have plus 1 plus x. We now have plus minus what? 8 equals to 0. Okay, so it means that we were looking for x. X will be equals to minus 8 to this side will give us plus 8, and plus 1 to this side will give us minus 1. So x will be equals to what? Equals to plus 7. And that is where we have this manganese to be plus 7 in the naming of that compound using oxidation number. So the potassium tetraoxomanganate 7 is from its oxidation state in this very substance. Very simple. It is nothing to bother about. Very simple. Now let us see how we can also determine the oxidation state of chromium. Oxidation state of chromium in this compound, which is what? Potassium heptanoxodichromate what? 6. The naming of this compound ending with 6 is because of the central role of chromium in this compound and from its oxidation state in the compound. Now, how do we determine its oxidation state, which we said is 6? Alright, now we're going to clean this to allow us to do that. Okay, now to determine the oxidation state of chromium, that means we are looking at this now. So we'll have that. There's 2 here already. So 2 to the oxidation state or number of potassium plus this is 2 to the oxidation state or number of chromium plus 7 to the oxidation state or number of oxygen equals to 0. The 2 is for this, the 2 is for this, the 7 is also for this. Okay, now we know that, potassium is +1, and we know that chromium is what we are looking for, and then oxygen is -2. So we put this into this equation. We are going to have 2, which is this. Oxidation number of potassium is +1 plus 2. Oxidation number of chromium is what we do not know, X, plus 7. Oxidation number of oxygen is -2 equals to 0. Now we can work this. 2 times 1 will give us +2, plus 2 times x will give us 2x, plus 7 times this will give us -14 equals to 0. When we bring this out, we have 2 plus 2x minus 14 equals to 0. We are looking for x, so we will have 2x is equals to 14 minus 2. Remember, this is moving to this side. So it means that 2x is equals to what? Is equals to 12. Divide both sides by 2. We are going to have what? We are going to have x is equals to what? Equals to 6. Now, that means that chromium is equals to +6. Now, this is where the +6 for chromium rather is coming from. So the oxidation state of chromium, oxidation number of chromium in potassium heptaoxo dichromate 6 is from the chromium, which is here. And with this, you'll be able to tell if there is if this chromium take part, if this particular substance take part in a reaction, and you have an increase in the oxidation number, you know that there is oxidation reaction taking place. If there is a decrease in oxidation number of chromium, you know that this entire compound has taken part in the reduction. So you can see how it goes. Now finally, let us see that for hydrogen, that for sulfur in hydrogen tetraoxosulfate 6. How does the 6 come out? How does the 6 come about? Which supposed to be, which have been used rather to name the hydrogen tetraoxosulfate acid. Okay, now we can also do that. We are told that 6 is the oxidation number. Of course, when you name it orally, you will know that it is true. Hydrogen tetraoxosulfate 6. So the 6 is the oxidation number attached to sulfur. But how was it calculated? We are going to do that. So we are going to do the same thing. So let's also put this aside. Now with this, we see that hydrogen here is 2. So 2 times oxidation number of hydrogen. Now, okay. And then we see that sulfur is what we are looking for. There is no 2, so it's sulfur. We see that 4 is what we have here for oxygen, equals to 0. Alright, I know that you have already solved it. You already have the answer with you and the process of getting it. Okay, Now, with this, it means that hydrogen is +1, and then sulfur, we are looking for it, and oxygen is -2. So we are putting this to this equation. So we have 2 times +1 plus x plus 4 times auxiliary number of oxygen -2 equals 0. So 2 times this will give us +2 plus x minus 8 equals to 0. So this will give us x is equals to 8 when this moves this way, and then -2 when this moves this way. So x will be equals to what? +6. Now you can see how sulfur arrives at +6 as oxidation number, and it is used to name the compound hydrogen tetraoxo sulfate 6. Now, so much has been done on determination of oxidation number. I know that you must have learned something very good from his class today. Do not forget to share, do not forget to like, don't forget to comment, and do not also forget to subscribe. And follow as well in my Facebook page, Dr. B Chemistry, Dr. B Science Classes. Until next time, it is a bye for now.